Today we chat complex numbers. So as we were kind of saying in the example before I started the video, if you try to take the square root of a negative, it don't work. Let's even check it out here again. Yeah, non-real answer, can't do that. So in their craze, I don't say infinite wisdom in this case, mathematicians didn't like that. So they created this imaginary unit, I, and they put a value on it. The value of I is the square root of -1. So the calculator won't do this, but we can. And so what we're going to end up doing is, if you try to take the square root of a negative, you're going to be able to do it now. And I'll show you in a minute. We'll get a little prop going here with it too to kind of help with this. So the best thing I can tell you to do to try and help is that this whole I thing kind of goes in a 4-part cycle. Okay? So I'm just going to kind of number my little boxes here. Because if you can figure out the pattern with this, it makes figuring this out easier when you're dealing with it in a problem. It takes a little time, but we get there. So, bless you. So when we have I to the first power, okay, that's the square root of -1, but we're just going to put I here in the first box. So if we have I to the first power, it's just I. If you square I, so let's think about that for a minute. That'd be the square root of -1 times the square root of -1. The square roots would just cancel and leave us with -1. So I to the first power is just I. I to the second power is -1. And then as we keep building, I'm going to go to a Post-it note here because I don't want to scribble all over the place. So I to the third power would be I times I squared. Because again, exponent rules, add the exponents. So I squared is -1. And then I squared is just I. So this is going to be -I. And we're almost there. I to the fourth power is I squared times I squared. Well, I squared is -1. -1 times -1 is +1. You're like, why exactly did you just do that again with all those? Because here's what happens. Once you get through the first 4, the cycle just starts back over. So like if you had I to the 5th, it would be I to the 6th, I to the 7th, I to the 8th, 9th, 10th, 11th, 12th, and go on and on forever. It's going to make it go much faster when a little later in the packet, we start doing weird things like I to the 22nd. Okay? It's going to be a fast way for us to be able to get to the answer instead of having to count round and round in this quadrant forever. I mean, we could, but that's not real good time management. So it's going to be weird at the start, but like I said, I'm going to have some ways to help. So here's how this works. I can't put this in my calculator, right? But here's the deal. Now, when we see a negative under the radical, your job is to pull an I out. Okay? Now, not that kind of I, that'd be kind of gross, but if you pull the I out, it pulls the negativity out. I mean, it'd pull anything out of you if I pulled your eyeball out, but we're not going to go that route. But now the square root of 49 is just 7, and I can actually do this now. And so now we have this new trick, this new tool, that whenever I see a negative inside, once I pull the I out, I pull the negativity out, and I can hopefully break down what's inside the radical. It's like any radical, though. Sometimes they'll be perfect squares. Sometimes they won't. And if they're not, I just have to leave it. But I will say this, your I always has to come out from under the radical. You can't put square root of 7I. We don't want the I under the radical, because then it's kind of defeating the purpose. But other than that, like for instance here, I'm going to treat I just like I would an exponent, just like I would a variable. That squared's going to both of these. So I've got negative 5 squared and I squared. So you're like, all right, 25I squared. But I squared is really negative 1. So if that's true, then this is really 25 times negative 1, or negative 25. Okay? I squared is the exception to the rule that you can't just stop. We can't leave I squareds. We can't leave I to the fourths. Any even index that you get, any even exponent that you get is going to be able to be simplified. So in some ways we treat it like a number. In some ways we treat it like a variable, which makes it kind of special. And so when we go to write these, if we have them involved with problems with coefficients, constants, things like that, we're still going to treat them like they would be x, okay? So the complex number, we have the real part, and then we have the imaginary part. It just means the imaginary part has I. So like if I'm looking at 7 plus 3i and I'm trying to label parts, 7 would be the real part. 3i would be the imaginary part. So you're like, okay, that's kind of straightforward. One thing that actually is. Well, but what about this? Like, what about where you get into a part where there's a fraction like this? With this, it's going to be easier if I kind of break it apart like this. Because now I can say, well, this part has I, and this part doesn't. So all I'm looking for when you're kind of hearing about put it in A plus BI form, that's it. Be able to tell the difference between what is I and what doesn't. There's not a whole lot else to that part. So this is like exponent rules meet radicals meet combine like terms, and it can get to be a little bit funky. So we can do all the normal things we do with a variable with I. Okay? The only thing you have to simplify further is I squared. So if you're looking at straight combining like terms, you're still going to find the constants. You're going to put them together. Remember here, you're adding. Don't mess with the exponents. 1i minus 3i is negative 2i. That's all. I can't do 3 minus 2i. This is like it as a variable. That's I, not I squared. Don't turn it into something. That's it. You're finished. And so when we're looking these through, let's see here. Positive and negative 5, they just cancel. Okay, well, that wasn't bad. But those detailed things that we tend to forget at times, that's the same thing we're still watching for now. So like if I'm doing 12, okay, the first set of parentheses, the first quantity doesn't have a sign in front of them. So those parentheses are kind of not needed. But here that negative has got to get to both terms. And now it's just like number 9 was. Okay, now for the most missed question. Well, the second most missed question on the next quiz. When we get to 13 and 14, okay, you have binomials that we're multiplying. You have to FOIL these out. It's not just first, second, second, and we're done. So here on 13, for instance, So we'd have negative 12 plus 6i minus 4i plus 2i squared. So there's a couple of things going on here that I have to pay attention to now. The first one is, ooh, there's I squared. I squared is negative 1. So this is actually negative 2. So when I go to combine like terms, that's negative 12 and negative 2 is negative 14. And then I can combine my regular i's here in the middle. Whenever you get I squared, immediately brain has to go to, ooh, that's negative 1. Okay, I got to fix that and work it through, because otherwise we get in a little bit of trouble. Play it back one more time here. Negative 4 times negative 1, that's really just positive 4 now. Negative times negative is positive 29, and then positive and negative 10, I just cancel this time. So, okay, I just got the number. That's cool. So treat I like you would a variable. Okay, you can add exponents on it. The only difference is it can change its identity if you get to I squared. Now, this is another part, again, that can be fun. Originally, most of the time, I'd say, okay, I'm just going to multiply those together. Negative times negative is positive 45. But here's the catch. With the negatives in there now, you have to deal with those before you do any other operations. So here, I need to take an I out here, and I need to take an I out here before I start. Once I've taken those i's out, now I can go ahead and multiply what's underneath the radical, whatever operation that is. I can multiply, divide, do whatever I need to do. And if your radical breaks down, it doesn't have to just be a perfect square. So I notice a couple of things here. I'm like, ooh. Okay, so the square root of 9 is 3, but I squared is negative 1. So I'm actually going to write it out this first time. So this would be 3i squared times the square root of 5. But I squared is negative 1. So 3 times negative 1 would be negative 3 times the square root of 5. So if you need to go in steps at the beginning, that's not a bad thing. Okay? Speedy isn't necessarily going to get you to the right spot with these. So I'm taking a moment. I'm freeze framing. We're freezing. Try out 16. It'll be interesting. A couple different ways you can end up tackling this one. Prep you for both here before we unfreeze. Take a look here. There's a couple of ways, maybe. There we go. There's a couple of ways you could have tackled this one. So either the way I did it right under the problem is probably the way I'd go after it. I noticed the 16's a perfect square already, so I went ahead and broke that down. That's 4. So 4 times 2i would give me to 8i right away. And then I just multiplied what's going on outside the radical. 40i squared, 40 times negative 1 is negative 40. But you could do like we did in number 15. Multiply the stuff on the outside together once I is there. Multiply the stuff inside, the 2 times the 16, and then break down 32, which will end up going back to the square root of 16 anyway, but you end up in the same place. So we're going to start combining lots of things that we've learned already, breaking down radicals, exponent rules, all that stuff. So we just got to have ourselves ready and raring to go. Okay, last thing up here, because this one's a little funky as well. You're like, ooh. Okay, Hardy, how do I want to handle this? So I could add the exponents and get I to the third. I don't really like I to the third. I like I squared because this is just 4 times negative 1. So if I have negative 3i times negative 4, now I just multiply those together. That's going to be easier. Can I still get to the answer with negative 12i to the third? Yeah, but now I got to go back to my little chart or remember that, that's negative I is what that equals. So anytime you see I squared, I always do that first. Just trying to give a heads up on that. Any issues so far, besides the fact this is kind of weird? Okay. Already know. You remember when we said before we can't have radicals in the denominator? We have to rationalize them. Yep, i's the same way. No i's the denominator of your final answer. So we're going to rationalize them as a complex conjugate. Ooh, that sounds so fancy. Here's what that means in English. Whatever you have in the denominator that includes I, its conjugate just means you're changing the sign in the middle. So if that's 2 minus I, I'm going to multiply numerator and denominator, not just one, by 2 plus I. Yes, you're going to have to FOIL all this out. So this is going to be a little chunky for a minute, but that's all right. So we got 10 plus 5i plus 2i minus I squared up top. And down below, we got 4 plus 2i. I'm going to show you a shortcut too. Minus 2i minus I squared. Okay, couple of quick info bits to help you out. Do not start canceling stuff here. That is not going to turn out well. We need to simplify first. So let's see here. Negative I squared. Negative 1 is plus 1. So 10 plus 1 is 11 plus 7i. Down here, positive and negative 2i cancel. That'll happen every time if you multiply by the actual complex conjugate. So we got 4 minus negative 1, which is positive 5. No more I in the denominator. I'm done. Did I do something? I did something funky. I just noticed it. It's a little thing, but I just noticed it. That's positive and positive. That's plus. So if that's plus, that's 10 plus negative 1. Okay. I don't know how I noticed that. Something just didn't look right. See, even me. Detail work, people. Detail work. And so, when you're doing these, do I want to go to 20? I want to do one thing on 19. I'm not going to go all the way through, but I do want to mention it. So here again, when you're multiplying by your conjugate, make sure that sign in the middle is always the opposite of this one. The foiling's going to be the same. The simplifying's going to be the same. We just got to make sure, because if the signs aren't different, you're not going to make the I go away. Which would bring you to this. You're like, okay, what the heck do I do on this then? If it's not a binomial, if there's not a plus or minus there, you don't have to play the sign game. You can just multiply by whatever that is, because let me show you how that works. Little distributing to do. So I squared's -1, so that'd be -14 plus 21i. That would be 49 times -1, which is -49. Okay, here comes the good, better, best. This is really good. It could be better because there's a number that divides into all three of these. 7 does. So if we divide each of those by 7, okay, that would be best. You could even divide by -7 if you wanted to, with all of them to get it reduced to its final form. So always take that one moment at the end just to make sure, but it's got to be all three parts, not just two. All of them to make that work. Like, Hardy, are we almost there? We are. We are. This is another one of those things. It's got so many uses, though, that makes this interesting. Now, this looks like a cluster. This is going to be the easiest thing we do. Find the values of x and y that make the statement true. Whoa, y, x, I. How the heck are we going to deal with all this? We're going to break it into a real and an imaginary equation. So here's my real parts, the 2x and the -14. We're going to make an equation out of that. And then we're going to take the imaginary parts on each side, and we're going to turn that into an equation. And we're going to solve that, because we're just looking for x and y. Well, the x, okay, that's not bad. Okay. Y. We're solving for y. What's being done to y? It's being multiplied by I. I don't like that. So I'm going to divide by I. Cancels out the I there. Cancels out the I there. I've got my two answers. So as long as you separate it into real and complex, or real and imaginary, nothing real bad. And it's also going to allow us now in something that we've already done. Again, I'm not going to go crazy. But now, instead of when you get to something like this, saying, all right, subtract the 5, take the square root. Oh, Hardy, I can't. It's no solution. Oh, not anymore. Still plus minus. It's still a quadratic. It still is going to have two answers. Pull the I out, and you're there. But notice where the I is. The I is inside of the plus minus. You don't want to have I plus minus square root of 5. That's a different answer. That's why we do the plus minus right away. Then we break down the radical, because that's how we make sure order is going to work out on things. So can this get funky? Yeah. No square root yet. X squared's not alone. Now we're ready to play the square root game. Oops, almost lost my eye. If the radical can break, though, this is the point we're going to break the radical down. And this is the point that radical that breaks down stays with the I. We will get to some problems down the road where that plus minus, there will be something in front of it too. We're not there yet, but we'll get there. And so we just keep playing. So one more piece to the puzzle here on the bottom, and then we got an easy app, and then we're done. Even though it's a lot of stuff to keep track of. These are what I was talking about on the front. Now here's another version of the little chart. And again, some of you are going to decide you're just going to count and count and count, and that's fine, but we don't need to do that. So for instance, I to the 20th. Now could I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, Hardy, it's 1. Got it. Okay. Easier way to do that. Notice there's 4, and then the pattern starts over. Okay. If you go ahead and you try to see as you're going along, things are kind of divisible by 4. If you see that it goes in evenly, and here's what I mean by that. I'm going to put a little note out here. If I were to take 20 and divide it by 4, I get 5. There's no remainder. If there's no remainder, it's this I to the 4th value. So if I said it was I to 100, it's 1. If it's I to 64, that's divisible by 4, it's 1. But if you try doing it and dividing by 4, and you have a remainder, oh, heck, why not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, 25, 26, 27, 28, 29, 30, 31. I like this better than counting 31 times, especially if I decide, like on the quiz, to put I to the 82nd or something crazy like that, and I hear some of you out there tapping like 80 times, I'll be like, oh. So either one works. But if you want a faster way of doing it, dividing by 4 and looking at the remainder is going to be the easiest way to get you to the speed that you want. And we get to finish up easy, thank goodness. Hardy, for the love. Ooh, applications. Did any of you ever know that like most cell phones and computers run off of coding that runs with imaginary numbers, like with all the zeros and ones and things like that? Just something to look into. Okay, easiest part of this, even though it doesn't look like it. You don't have to know anything about electricity to do this. Okay? In a circuit, the voltage, current, and impedance are related by this formula. V equals C times I. Times. Find the voltage in a circuit with this many amps and this much impedance. All you're being asked to do is take these and FOIL them out. So we just got to pay attention to that. So we're like, all right, 18 minus 6j plus 36j minus, whoa, 12j squared. Hardy, do we treat j like we would treat I? Yes, you would. So here, when you're working this out, that 12j squared, even though it doesn't look like j squared, that j squared still is a negative 1. So negative 12 times negative 1 is positive 12. Because electricity works on these complex numbers. But it doesn't mean every time you see electricity, it's multiply. Current in one part, current in another. Add, I mean, it says it right there. Add, combine like terms to find the total current. Okay. 12. 9 minus 3 is 6. No I squareds. That's the end. Okay. So here's the dealio. And I'm going to say it right off the bat this time. I'm even going to encourage it this time. When you get to complex numbers, there is a lot here, but you also notice there was a lot of different things we did. Straight odds is fine as long as you are doing them legitimately and not just writing down the answers you want to know. Okay? There's plenty of odds to get you practice at what you need. But as usual, if you want to do some evens, or you see an even, you're like, I'm not sure about that. Let me try it. I got all of them up here. Okay? The key up front will always have evens and odds. But if you want to see how something worked or how it changed, feel free. Check something out. Take a pic. Whatever you got to do. And play. Lots of different things, but they do go fast. They do go fast. So play with that a bit. We'll start to ease up and slow it down towards the end of the week here. Get you some time in class to be able to work a little bit too. So that's kind of important. Oh, and I've forgotten to hit